All right. We've got another live stream kicking off. It must be Tuesday because it is time for another Nemotron Labs live stream. Hey guys, how you guys doing?
Never been better, man. Happy Tuesday to everybody. We got an awesome guest today, so that's perked the mood up for sure.
Yeah. And Chris is serving us today from the he's cooking in the kitchen. So we got him there in his fancy space with the stove. Matt's matching in his space. Hey Matt, good to see you.
Good to see you as well. Thanks for having me.
Absolutely. So I want to preface this week's live stream with how did we get Matt? And I'm so excited that Matt's here. Matt and I have done multiple things over the years together, and we've been talking about these new models from NVIDIA like Nano V2. And I know Matt's always got these amazing applications where he's pushing sort of the boundaries of what agents can do and what you can do with prompting. We'll make sure his information is up during this stream. If you don't follow him, make sure you guys do, because his projects are just spectacular. I have so many questions about Sora and other things with you in the future, Matt. But I reached out to Matt and said, hey, we've got these amazing models. Do you think you could try it in some of your applications? And Matt just immediately was like, oh yeah, no problem. We can do that. We had an open router endpoint. I think that's what you ended up grabbing it from, right?
Yep, exactly.
Yeah. So I think, well, before we get too crazy going down that road, I guess let me introduce everybody today. So I see some folks are joining us on the stream. Thank you guys for joining us today. Make sure in the chat you tell us where you're from, what you're working on. Let us know. We're always excited to learn what the developers are doing. So we got myself, Mark Heaps, working here at NVIDIA, now coming up on week 12. So I guess I can officially have the green in the background as an NVIDIAN. My good buddy, Mr. Chris Alexia, always try to make sure I get that name right. He's one of our product research engineers. And Matt Shumer, CEO and co-founder of Otherside AI. I want to get into a little bit of what Otherside is in a second, but Matt, could you just do a quick introduction and then let's take a look at this demo and then we'll unpack it for everybody.
Yeah, sure. So my name is Matt. I've been in this space since 2019. So in AI years, almost, I guess, 100 years or something like that. Yeah. In that time, I've done pretty much everything from, starting companies. So I started Otherside AI, which is the creator of HyperWrite, which some of you might know as one of the largest AI writing tools in the world. Almost 4 million users in something like 150 countries at this point. Wow. So that's super exciting. I've also built a number of open source projects that have gained a lot of steam and invented and pioneered some of the techniques that are used in training and inferencing large language models and AI models in general. Today, I also invest. So I have a fund as of very recently called Shumer Capital, basically investing in early stage and up to Series A AI startups. So I kind of see it from every angle. But my favorite thing to do is to build. And hopefully you'll see that today in some of the stuff that I've done. Very excited to do this with you guys.
This is why when I started working more closely with developers in the AI space, one of the things that I like outside of your typical sort of Twitter influencer and those folks is people that actually get really hands-on and build and make things. And when I first discovered your work, it felt like you were just churning out something week after week after week after week. And it was just like amazing to me at the rate at which you were producing. And I think you were the living embodiment that proved to the world, like, someone that works with AI, not just building AI, actually can be like hyper productive and can 10x themselves. So that's why I reached out. So I think let's start today with the demo that I mentioned, where I reached out and said, hey, can you use Nano? And then we can start unpacking that, like, explaining what it is during runtime and more. And while Matt's pulling that up and getting it going for us. Hey, everybody that's joining in the stream. I see you guys in the chat. Lots of good questions coming in already. I think this is gonna be a good one today. People are excited.
It's always nice to see the chat popping off. And I mean, watching a demo, the best part of the day. So.
Man, we've got questions even about space travel already, Matt.
I don't know if I can answer that one, but can show a demo.
All right.
Just realized there's a mistake here. Fix that.
All right, let's see. And I'm going to add your screen to the stage. So let me add that real quick.
Fantastic.
All right. I see your collab up. So let's venture back to what was, I think, 2 weeks ago.
Just about.
Yeah. So you have this app. So what is the app first? Like while you're getting this going?
Well, the app that I'm running this in is something called Google Colab. Think of it as an interactive, runnable Python environment in the cloud, so you don't have to have anything installed. That's less important than what the code actually is and what it does, because that can run kind of anywhere.
Mm-hmm.
So the general concept behind this is, can you take a model that is, let's say X good on its own, and through clever inference techniques, make it Y good, right? Make it better. And there are many complex ways of doing that, but this is just demonstrating a much more simple approach that kind of just works. It's somewhat of a brute force approach. Yeah. So this is what I call pro mode. It's in spirit similar to, although we don't know how similar technically, to what OpenAI does for GPT-5 Pro or O3 Pro, or what used to be O1 Pro, where essentially you take the same base model and you find a way to use more compute with it to get the answer to be more intelligent, better, more reliable, what have you. So this is very simple how this one works. And I can scroll through the code. That's less important. I could just kind of talk through it. So what happens is when we go down here, you give it a prompt, right? This is a very simple prompt, but you could do anything just like you would do with a normal language model. And you choose how many candidates you want to have. And candidates are just saying, how much power do I want to put towards this task, right? How many instances of this model do I want to throw at the problem? And you could do 1, which is just the same as doing like a normal prompt in a normal model, or you could do 100. And it could keep scaling, right? Obviously, there's some diminishing returns there, but right now I have it at 5. So what's happening here is when I run this prompt, it's going to generate 5 different instances of Nemotron, not just 1. And it's going to ask the same question to all 5. We're running it at high temperature to get some creative variance. Obviously, from what I've heard since, I should be doing it with a slightly low temperature, but I think this is the right approach. I don't know. We'll see. And then we're going to generate 5 different versions, right? Or more if we want. Then we sort of take these prompts and these completions and we put them in one mega prompt. And the nice thing about Nemotron is it sort of has a hybrid SSM architecture. So it's able to handle long context pretty well. So it can handle a lot of these candidates at once, much better than other models, which is super exciting. And great job to you guys on doing that. It's a great decision. What we then do is we take another instance of Nemotron with all these in the context window and say, okay, here's the original prompt the user asked for. Here are a bunch of different options for ways to respond. Now, I don't want you to just pick one. I want you to look at each of them and say, what's similar about them? What's different? Are there any issues where maybe one thinks X and the other one thinks Y? Which one is more likely to be right? Let's take the best of each of these outputs and build sort of an incredible overall output just from all of them, basically taking the best from each to build something better than could be done in just one pass. And what this enables is, like I said, more inference, more compute, more power from one model to get better results. So you can theoretically take a model like this that's, I think, 9 billion parameters and get it to perform like a model that's significantly larger, maybe 70B, or maybe even more if you do a number of candidates that's quite a bit higher. You can even stack these. You can do sort of the same approach, but sort of like in trees, right? So there's all sorts of interesting ways to do this. Let me show you what it looks like. So I'm just going to do a simple prompt at first. We're going to explain the concept of self-play and reinforcement learning, right, with an example. So I'm going to run this, and it should be pretty quick. The model is super small, which is great. Right, if we were running this, let's say, 70B or a, trillion parameter model, this might take a second. But
yeah, that might take a little
hopefully
while.
This will be relatively quick. So,
and I think that's one of the topics that keep coming up is, how do you leverage these smaller models? Because you then have more control over what your scaling does in an application code base like this, because your cost per token is significantly less when you're using those smaller models, right?
Yes, and one of the things too is, right, so you could have a larger model that takes maybe the same time as a smaller model run 20 times over, but the larger model might have an inference time that's like feeling faster because the time to first token is lower, but maybe you're going to get a little bit more performance out of the 5x or the 20x smaller model setup. It really depends on your use case. But you can see here, so here's what it did, right? So we got our final answer here, up here, right? And it gave like one sentence that was very clear, or not one sentence, one paragraph that's very clear, with an example doing exactly what I asked. Now you can see what the sort of like precursor candidates were, and they're a little bit less clean. They're more like GPT style, right? They're a little bit more ... 1, 2, 3, 4, 5, and they're good. But you can kind of see if you go through this, and like it's kind of hard to do on a quick stream. But if you look at this, I can guarantee that, like, see, this one was probably really good, but way too complex and way too over the top. you can see that we kind of took the best of all of them and threw them in here. Now you can do even more complex things with this. So funny enough, when we were doing like a prep stream, or I guess whatever we call that,
little dry run.
Dry run, yeah. I was kind of curious, and I was like, okay, how can we actually make this output a little bit cleaner? Because you can see it's a little hard to follow, right? There's no sort of organization here other than just like these like lines. And as kind of just a little fun test, I tossed this code that builds this whole system into GPT-5 Pro, or sorry, GPT-5 Thinking, along with a prompt to say, like, make it look better. And then I was like, you know what, why not try Nemotron with 10 candidates as well, thinking it wouldn't be nearly as good. And I was shocked. We all were shocked when we saw that actually the one that was better was the Nemotron-driven one. I don't know if this is going to work again, but it is worth trying because you never know. Let's see.
This is why we do live streams and real-time demos.
So I'm going to write a quick prompt here. Make the prints to the console clearer. Show progress as outputs complete individually. Or something like that. We can run this. I probably should have done a higher end, but it's fine. This might not work, but worth a shot. And we're going to see this go. Hopefully within about 20 seconds, we'll have an answer. And then I will paste it in and we'll try it.
And Chris, did you have a question?
I was just going to say, like, it's this, I mean, you know, not to beat the drum too hard, but it's this idea of like, you know, faster models or smarter models. And this kind of, you know, idea of exploring many different, you know, avenues and then choosing the best or synthesizing a single best response from them is just one way that you can kind of see that take shape.
Yeah.
Okay. So we need to take the one completion, pro mode. So down for one completion. Hopefully that worked. We'll see.
And I think just, you know, as a methodology for people that maybe are newer to this work while we're going here, what have you found as sort of the global maxim of this stacking methodology? Like what led you down this path originally, Matt?
Got it. So that didn't work. So as I mentioned, like we can move on. I would hope that with one or two more tries it would, but not worth, you know, spending a ton of time on this. You guys saw it, don't believe us. So the philosophy behind this is pretty simple. Like my belief is more compute when used wisely will lead to better outputs. We've seen it in, you know, our company's work. We've seen it in the projects I've done. It you know, this works on almost every level. Even an example is like, you know, now JEPA and DSPy are a thing. The original approach I used there back in like maybe 2022 or something was I released a repository called GPT Prompt Engineer, and basically did a similar approach. And the idea is like, if you just apply inference time compute, but not towards like the actual output, but on the prompting and building side in advance, you know, that'll improve results. There's all these different ways to do this. This is just one example. And I think this is sort of like a building block. I think you can stack these together if you do this super well. Like there's so many ways to improve it. General approach is, why would you rely on the model just one time to get the thing right? When you could say, okay, we know this model has a possibility of getting this right 1 in 25 times. If we run this 25 times, we will get one of the right answers and we'll be able to find that. Models are much better discriminators, verifiers, than they are generators. So if the right answer is there, it's very likely to find it. You just have to get that into the context window. So this is just an approach to doing that. There are many others. I've done work with some folks where, you know, we benchmark these approaches and they do work. There are diminishing returns, but I think there are easy ways to overcome those. But in simple, it's just more compute, better results.
Yeah, I think Chris and I were having a conversation after we met last time that was interesting to me. This idea that, you know, so often when you're doing single shot work, you're trying to find this perfect balance of temperature and you're trying to figure out like what is exactly the right prompt to get this perfect answer back. But when we were chatting about it, Chris, I think you were saying something to the effect of, you know, allowing a model to be a little bit more creative with its temperature allows you to get this greater variance. And that's where you really activate this methodology. Am I representing that correctly for the audience?
Yeah, I mean, I think the way I would put it, the way that I would put it, right, is something along the lines of, so reasoning models have a lot of like baked in variance already. So the reasoning traces are often quite different between, you know, actual generations. One of the things that this means is that we kind of have this built-in like explore piece, right? Because when we're talking about getting better at a problem through trying to synthesize from many responses, we as Matt said, we want to have this like really large sample of potential responses to pick from, right, or to combine. Mm-hmm. And so having, you know, the reasoning models with that built-in temperature of like 0.6, which is kind of what they're trained on, a lot of them, is super helpful because of exactly that. It lets us have this larger playground to come to a final synthesized response. Mm-hmm. And this approach is like best of N approaches, which we know, you know, from the literature, work really well for like Matt said, like one of the examples of test time compute or inference time compute, which is, you know, obviously the bigger the underlying model is for inference time compute, the more time it's going to take to generate those responses. And so this avenue is a way to allow these smaller, fast models to kind of punch in the same weight class as these larger, slower models with the same unit time, right? And I think that's something we talked about at GTC San Jose last year, and we're going to continue to talk about, because it's, you know, again, it beats the drum of faster models or smarter models, and that this is why, right? Because we can do stuff like this.
The cool thing also is you can apply this exact same technique to the biggest model you've got, and it immediately becomes smarter, right? There's just like it opens up so many doors, so many doors.
Does it also, as an approach, Matt, does it also give you this ability to be more malleable? And what I mean by that is, I imagine, you know, the applications that I've seen built by devs, you know, sometimes there's a lot of work to find this perfect sys prompt in what you're doing. And then when you take this approach, in essence, you can create all of these different experts that you're, you know, the committee that you're creating, so to speak. But that gives another tunability, right? Like you did 5 there, but is that some of the work that you've seen where you literally ratchet this up and down and say, hey, how big of a committee do we make until you find that sweet spot, right? It's just a completely different dial for a qualitative result in the application.
Yeah, I mean, not just that, you know, there are ways you can alter this approach. Like you could think of this, and this is all open source on my GitHub. Feel free to go and rip it and use it. You can alter this in a number of ways. For example, you can actually not just have, like, let's say 5 generators of the same model with the same exact approach. You can do different models. You can have the NVIDIA Nemotron model. You can have the one, I think you guys mentioned there was another company that trains using the exact same data, a better version.
Yeah, that was ServiceNow. They just released their model. It's on artificial analysis. And interestingly, they took their model, but used the training data we provide for free and give everyone access to. And then they beat our own model in the artificial analysis results, which we love, right? Because we want everyone contributing.
Yeah, 25% of their pre-training data for that Apriel model was directly from the pre-training data that's part of the Nemotron open data sets. A small interesting tidbit on that model, just for funsies, is that there was actually no RL phase for that model either. They actually got the reasoning improvements through mid-training improvements, which is just another place that we have to make these models better and faster.
Was that a smaller model then?
Yes, it's a 15 billion.
That makes sense
model.
Then. Yeah. Oftentimes what you see is on smaller models, SFT just works better than, or even mid-training works better than RL, which is super interesting. So I think you also have to sort of like RL them differently, because, like, for example, just distilling them doesn't, from what I know, doesn't work super well, because it's going to try to emulate a strategy that a bigger model might take, that it has the ability to take, whereas a smaller model might not. But back to sort of the point. In theory, you could do almost anything with this. For example, let's say the 5 experts right now are just pure plain vanilla 5 experts with no extra prompting. For example, what if you wanted to have one that's more focused on the emotional side of the response, or the sort of formatting, one that's more focused on, you know, sort of like higher order thinking, one that's more focused on, like, what is the user going to want to see here? making each of the experts sort of more focused on a specific thing, and then having an orchestra expert taking a look at what each of these would be probably good at. Or even taking this a step further and saying, okay, let's do 5 separate pro mode runs. This run is focused purely on the emotional side of the answer. This run is purely focused on the intelligence side of it. So like there's all these different ways you can do this. I think it'll enable like a lot of interesting use cases. It's very different for each thing, but think of it as
and this is like this approach, right? We have similar style approaches and like mixture of agents, right? Where we're talking about having, 5 different LLMs representing 5 different facets of generation. And again, it's just a way to build a harness to facilitate this, using those sweet GPUs to help us get to a better answer instead of just help us train a bigger, better model.
So I think that was one of the questions. I'm going to bring it up on screen here from Runfish. That asked that, which is better, 6 thinking hats technique or injection of random exotic keywords? And I think I've seen some posts about this, like getting a little bit more specific in the language, but I've seen that topic even expand into whether people are using Markdown in their prompting formats and all of this. That seems to be a topic that you're very passionate about, Matt. So what's your thoughts about this?
To be honest, I don't know what either of these techniques are. Do you have any more context?
I don't see that he has anything else.
I think, like, loosely speaking, the answer here is going to be 6 thinking hats, which I believe is what is being used as a shorthand to refer to the approach that we saw in the demo. The idea is that the 6 thinking hats, right, is they're all thinking towards the same goal. And so there's this there's this implicit understanding that every model is going to generate something useful, even if it's not fully useful, right? But there's going to be some scraps in there that we can kind of pick up off the table and combine to something good, versus like random exotic keywords. That's not necessarily an approach that you would expect to work. It can help to increase variance in your responses if what you want to do is like just throw in a random token to get real creative. But I would say like 6 thinking hats, or this idea of like best of n style scaling is typically quite good for all kinds of models from small to big. And n here, best of n, right? Like Matt said, it can be 1, which is single response. It can be 5. It can be 10. It can be, in some cases, for complex math problems last year at NeurIPS, we used some hundreds of thousands of responses, right? So you can really get silly with it and scale this thing pretty hard.
I'm curious. So what's the highest volume you've used, Matt?
I've used a couple hundred. That's it. I would love to go further, but obviously that's quite expensive. If you guys want to toss me some tokens, happy to do so.
We know some people. We might be able to figure that out.
Sounds great. One good shorthand, or like a way to think about a lot of this stuff when thinking about which approach is better. First of all, there's no way to know until you try it. And every use case is different. Oftentimes what you think might not make a lot of sense ends up being the right approach. But more often than not, the way to think about it is, if we had humans doing this, which approach would be better? So like you could think about this as like, okay, I have a math problem. Let's have 6 separate people solve that problem. And then a grader looks at them and says, okay, what did this person get right? Which step did this person mess up on? Right? Like that is just something that would probably work with humans. It'll very likely work with LLMs. That tends to be how I think about these things. People try to think of these things as something fundamentally new, but they are modeled after us in terms of the way they actually think, even though people say they're not. They have chains of thoughts just like we do. And you can apply them in the same ways.
Yeah, it's almost a structure of sort of probabilistic method. I know in the early days, Google was doing this with identifiers, like in the Google book scanning project, where you would have human moderators and bot moderators that were looking at like what is the content and more with these models. And then eventually the bot moderators were, replacing the human moderators because the probabilistic nature of what it would identify was getting more accurate over time. Yeah. And that was in the hundreds and hundreds and hundreds of operators for those tasks. So
well, remember back to Kaggle, right? Like everyone loves Kaggle on the leaderboards. Like what approaches did extraordinarily well on Kaggle for up to and including now is ensemble methods, right? Because ensembles, though they're not a new technique, they're almost always a technique that lets us spend more at time of inference, right? Or at after we've locked the weights, right, it lets us continue to spend more compute to get to a better answer, which is really the exciting part.
So we've got a question in here. Let me pop this one up. It basically says, how are you scaling the transformer token-based architecture based on the newer releases with more parameters? So Chris, I think this is probably closer to your wheelhouse.
Yeah, I mean, we're scaling to the moon, right? So the how is through a lot of really interesting, very well-built technologies, and obviously many GPUs. Part of also what we're doing, because that's like kind of the easy part, right? I mean, the framework needs to scale and the hardware needs to scale, but the data also needs to scale. And so we're scaling our data generation pipelines and our ability to produce high quality, well-curated synthetic data. I don't know if we got a slide ready, but this would be a great time to throw up a slide of GTC DC, which we're having at the end of the month, where we're going to be talking a lot about that half of the puzzle. But it really comes down to this idea of, hey, there it is. Yeah, come and join us for GTC DC.
We got Ethan in the background bringing stuff up.
What a legend! Thank you, Ethan. But the idea is, in order to scale this, you need to scale every piece of the pipeline. And so, I think in the old days, it was just like we had so much data, that we were sitting around on, that it was kind of like, how do we possibly get enough hardware, and how do we build robust enough frameworks to leverage it? Whereas now we're like, Ilya Sutskever, right? Big meme, said that data is a fossil fuel, right? And so now it's how do we build renewable data to continue to punch high above? Obviously, part of what helps that is the open model ecosystem, right? So your Qwens, your DeepSeeks, now Nemotron, models that are really permissively licensed for synthetic data use. That's a huge part of the puzzle, right? To continue to scale the transformer into big token counts. But as you'll see, it's not always about big, right? We also want to keep making small, efficient models that are really good at their tasks that they're designed for. Everybody wants to continue to do that, from GPT-OSS 20B to Nemotron 9B to Gemma. All of the model builders kind of, we have to scale the transformer to infinity, right? But also we want to make sure we have models that like people could use in like a day-to-day workflow. So
yeah, absolutely. And we're seeing so much excitement about things like DGX Spark and other smaller form factors, where when you start thinking about robotics, physical AI, when you start getting out into the field, what are these small models going to enable in these edge and hybrid edge environments as well? So I think I keep saying, anytime someone says they know where AI is going, I'm like, I don't think anyone really knows where AI is going. It is still pretty much the Wild West. I see some more questions in here, and I want to get to those, but I know, Matt, when we did like the dry run, there was a couple of things that you were kind of surprised by, like one, finding out that it was this Mamba hybrid, in the model. Are there, you get to be the champion representing the developer community today to us. What are some of the things that you're curious about that maybe we can try to help answer?
First, I actually am curious about the decision-making behind that architecture. I think in many ways it's a good choice, but it's not the normal choice today. You see a lot more pure transformer type stuff. So I'm curious how you landed on that, why you landed there, and are you planning on continuing with that architecture or just going to something a bit more standard?
Chris,
so I speak as a member of a very big, very incredible team. We have an incredible team of researchers that worked really hard on building these things. I'm just the guy who gets to yap about it. But I mean, the idea is that, transformers are great, but they suffer at really long contexts in terms of efficiency. And we know, especially with reasoning models, and especially with the way people are using models today, that they exist in these really high input sequence length, paradigms. We're shoving as much stuff as we can in the context in order to get the next best token. And I think that's a large motivator, inspired by the work of Nemotron H paper, which the research team published before. In terms of like literal what's coming next, I mean, you can imagine that this is an efficient architecture, and dropping an efficient architecture that performs well probably isn't something we're super stoked to do, right? So I think you can imagine that this kind of architecture is not going away tomorrow. And I mean, on that point, something that I really love to be able to say as part of this this amazing team of people is like everyone's in the kitchen. Like I'm in the kitchen literally, but they're in like the kitchen, you know, figuratively cooking up the next best Nemotron model, and like they're gonna keep making these awesome models and keep cooking new, you know, efficiency gains, and keep trying to push the needle on faster you know, models, right? Because as Brian Catanzaro, who's kind of like the head honcho, right, of this whole operation for Nemotron says, I mean, you know, being integrated across the whole stack, right, from the GPU all the way to our AI software, like that is Nemotron's how we test that and how we push the limits on that, right? And so you can expect that more models are coming down the pipeline with, you know, the same kind of efficiency that we've had already, and hopefully pushing the envelope as well. Yeah. But to answer the question simply, we chose it because it's fast at long contexts. It doesn't degrade quality of response, and because you can imagine that we'll want to try it bigger and better and better.
All right, excited to see that.
Nice. I do see Hillary has a question here. I'm going to pop it up on screen for both of you gents. Says, have you got any recommendations for situations where an LLM has multiple tools it can use and has to choose which tool to call to answer a given question? So Matt, maybe some thoughts from you first.
Yeah, I mean, I think the first thing is to have very clearly defined, very intelligently thought out, and very well described tools. Tools are just, to the LLM, another part of the prompt, right? That they can do something with. And too often when I have people come to me with like a, you know, an LLM prompt and tools that just aren't working well, the first thing I do is I look at the prompt and I look at the tools and I'm like, well, obviously it's not working well. I have zero clue what this is trying to do. Of course, the LLM isn't going to have any clue either.
Right.
You have to think about what are the simplest primitives you can give the LLM to get it to do things in the most efficient way possible, right? Make the tools really easy to use. They're just like people, right? You want to give them good tools. If you have shitty tools, you are going to have a shitty work product. It's not going to work. So that's the first thing. The second thing is oftentimes I look at the descriptions of these tools and they're just nonsensical. You have to make sure that it is so damn clear, like so clear. However clear it is, make it clearer, show it to your friends who aren't even in the space and say, can you figure out what this means? And once they can, that's probably good enough. But the thing is, like, so many people say, oh, you add too many tools to an LLM and it stops performing well. To some extent, that's true, but I see that mostly when the tools aren't described well. You would be surprised how many research papers I read where they say something doesn't work, and then I look at the prompts and I'm like, well, yeah, because you described it poorly, the model is not going to do it. I think a lot of findings in the space are actually quite wrong because of that. Like, people just don't know how to prompt and don't know how to describe. So really it is just like, think of the LLM like a person. How do you make it as clear as possible so the person on the other end would be able to do this? If a person can do it, the LLM will probably be able to too. Even a small model at this point can handle quite a few tools before degrading.
So going back to your demo then, is that a method that you've also experimented with, where you actually have your other responses, these other agents actually interpret and try to create clarity around the tool description and the function of the tool?
I've actually, not in this demo, but I've done more than that. Like some of the work I've done in recent past, this hasn't been published, but I've actually been working on reinforcement learning techniques to train a model to write better prompts. So keeping a frozen generation model and sort of attaching a model ahead of it that takes in your prompt and then tries to improve the output that comes out of the final model. So like taking a prompt and rewriting it. There's so many cool things you can do with that. Nothing in this project, but it's something I'm personally very excited about. You know, people shouldn't have to be able to describe things insanely clearly. It's obviously a limitation of where we are today. And I think, you know, scaling a little bit further will increase performance, but what probably will increase user experience quite a bit more is how do we make intent much more understandable? That's also something I'm very interested in. Chris, thoughts?
Intent-driven development, right? We're all talking about it. We, you know, it's a buzzword, but boy, is it important.
It's important.
I think too, like on this, you know, it's like the old days, all the way back in pre-2018, right? If you can even imagine back that far, you know, where when you build a classifier, right, or you build a system, you want to have these like really distinct boundaries, right, between decisions. And I think that's still how you want to approach things today. Like when I think about tool use in LLMs, I think about what would a classifier be like? Where would a classifier place this query, and how can I make sure my tool is set up to speak exactly to that? And it is all prompts all the way down, context engineering all the way down, right? Like it is the only thing that you need to do is make sure that it's clearly designed for your system. There are a number of ways to do this in automated fashion now. There's a number of ways to do this by hand still. There's still a lot of artistry, but it does come down to, you know, anytime the question is, how do I make LLM choose X, Y, or Z? Just really, really specific, well-defined, clearly drawn boundaries between X, Y, and Z so that we want to reduce confusion. And I love the suggestion of like, if somebody, you know, off the street can't tell the difference between when to use what versus the other, then like you have not yet done a good job, because LLM is basically someone off the street when you call it, right? Like they don't have whatever context you had when you designed the system. They only have what they're seeing in front of them now. And so I think that's really good advice. And you know, when we see these systems really fails, when we have really dense tools with very, very, very poorly defined lines, and the LLM just gets confused about like, what should I call? You know, if I have a tool called calendar and I have sub tools in that called like event, and then event adds an event versus looks at an event, right? Like there's no LLMs, it's up a creek to start, right? So,
right.
Yeah. Unfortunately, like a lot of the people working with LLMs are developers, and developers are used to working with sort of code where it's like, if this, then that, you know, if else. The problem is LLMs are really good at reading code, but developers often aren't good at conveying like sort of fluid intent, natural language intent. It's going to be a skill that every developer needs in the coming years, right? You're not going to be a developer if you can't convey intent, not just in building AI products, but even in using the tools that you have, like Codex, like Claude Code, right? All of these things require you to be able to clearly describe what you want. It's the most important skill. I often see, like, I believe in the next few years, you're going to have, you know, for example, former English teachers that are going to be better at building products than developers from last year, right? Because they're better at describing things. It sounds dumb, but it's so true.
It's a silly anecdote, so just permit me a silly anecdote for a second. But so I had a buddy that I used to work with a long time ago, and his background was actually linguistics, right? Like his study was the study of language. And I mean, the guy could prompt like you would not believe, because he understood language, right? And it's baking out like that ambiguity in language. It's baking in the information that you need in a way that follows the rules of language. And LLMs, while we meme on them for being next token prediction machines, I mean, the thing that they understand well are the rules of language, right? And so if you build prompts that are compatible with those rules, that are compatible with whatever language you're working in, you know, grammar, like absolute grammar structure, right? You're going to find that the LLM is just more likely to listen to you.
It's interesting you say that, because
you hit a. Go ahead, Mark.
Oh no, please go ahead.
I was just going to say, you hit on a very specific word there that's very important: ambiguity. Ambiguity is the enemy of clarity. Oftentimes, when people don't have their prompts working, even if they seem clear otherwise, you can kind of understand them, the LLM might be missing some sort of nuance there that's kind of ambiguous in your prompt. And when you see that, one of the best things to do is to run it with some examples. Say, why is this model obviously messing up in this way? Oh, wait, this part of the prompt that describes this behavior is a little bit ambiguous. Can we fix that? Like, that's one of the best ways to prompt. Get it as clear as possible, put it in the LLM, see where it messes up, and modify. Like, it's as simple as that.
I just giving Miriam a shout out here. She was happy that she's got her BA in linguistics. But I will say, from all the reporting out there, you know, going back 4+ years ago, what's interesting about this topic with where are people getting the ROI out of the AI enabled applications that are in the business environment? You know, some of the earliest adopters we saw were the people that were in marketing orgs, and more specifically communications orgs, where they're really having to interface. And I've talked a lot about Louis, this idea of a language user interface. and all of the signals that can be put into the models. But early on, they were kind of the non-engineer early adopters because they had this ability to express and communicate in many ways, myself included, right? My background isn't in engineering, and my degree is in fine art, and everything I did was around communications and marketing. But as soon as I started to get to work with NLP and some of these models that are out there, it was so intuitive to me, because it was just like being in a creative room with designers and marketers and writers, where you're just riffing around the table and you're iterating and you're shooting ideas back and forth, which I think is really why we've seen the ubiquity of these models be adopted in so many ways. Let's see, we've got a couple other questions here, and I want to make sure we get to some of these. I'm going to throw this one to you, Chris, because it's very NVIDIA specific. It says, what is the minimum NVIDIA GPU spec required for Nemotron? I think rather than get into will it fit on this product, like, why don't you talk a little bit about just scale fit and things like that?
Yeah, so the Nano series is meant to run on a single A10G class GPU. So whatever you have around that is probably going to be fine. All of the model cards have kind of like the minimum GPU specs, and I would use those as your spec Bible. Obviously, you can run it on different hardware using different quantizations, and we have an integration with llama.cpp, right? So you can use it with you can run it, like I said in a previous stream, like on a toaster with enough RAM, right? The idea though is that Nano series is really like, that's the one that's meant for that small scale usage. Our super model is meant to fit on a single data center GPU, which is very different. So it's still a single GPU, but it's not the one that you have it's not your RTX card in your workstation, right? And that's what that's built for. And then of course our Ultra, which is the largest model that we produce, is meant to fit on a single node, which means 8 GPUs. So that's the big boy. Again, you can play with the precisions, and GGUF, exist for these, and you can run it wherever you can be creative and run it, but that's what they are designed for. And that's where we're going to see the best performance for those. Nano for single GPUs, closer to edge, super for single data center GPU, and then Ultra for a single node, which is 8 GPUs.
And there's one here I think is very relevant for Matt as our guest with a high degree of expertise in agents. I'm going to pop this one on screen. It says, in which scenarios do you find LangGraph more suitable for developing agents compared to AgentKit, N8N, Zapier, et cetera? I think regardless of who your agent tool is, what are your thoughts about just the scenarios for using these sort of extra integrators?
It's funny. I have a bit of a different philosophy on these than most other people. I actually think they are overkill. You are going to get, so it's funny. Yesterday on stage, they did a demo with AgentKit where it was like, we're going to build an agent in 8 minutes. And it was like, wow, we did it. Realistically, it was kind of like a lot of copy pasting work. You can take GPT-5 Pro, which is already available, and describe the agent you want in words and say, I want you to build this out into a function that I can just host in the cloud in 10 seconds. And 5 minutes later, you will have a perfect agent that is well thought out, well structured, has observability if you need it, pretty much anything you need. And you don't have to go through the drag and drop, mess.
Yeah, the node base.
I feel like those platforms are most backwards, right? So I actually started as a non-technical founder. When I first started Other Side, I did not know how to code, or barely knew how to code. We built our entire product on Bubble, if you know what that is. So it's a no-code platform. It was hell. It was hell. We needed to. We'd raise money. We're like, we got to deliver. And we did. We ended up getting 20,000 users on that platform. But the second we saw how tough that was to maintain, we ended up learning how to code, migrating off. And, that's how I ended up getting into all this stuff. I don't believe that's the right approach. I think the best way to do this is to have models sort of just, you describe in words exactly what you're looking for. And you don't have to worry about relying on all this third-party infrastructure that can break, that can change. You can swap things out. I think instead you want to figure out what are the primitives you want to give to GPT-5 Pro that you're going to use in every project. For me, usually that's just OpenRouter and Disclosure. I'm a very, very small investor in them, but I think they're absolutely amazing. And then usually some form of analytics. That's pretty much it, or some logging. on the queries that need it. But I think oftentimes people very much overcomplicate agents, especially before they need to be, right? There's a point where, you want to have tons of these bells and whistles in your flow because you're scaling, you need to cheapen it, you need to monitor it in a better way. But especially in the early phases, I think a lot of these platforms are very much overkill and end up leading to tech debt in a bit of a different way. GPT-5 Pro with a very clear prompt and an open router API key is pretty much all you need. And the benefit there is you can switch things out. You can do all these sorts of weird things that might be incredibly hard to do with, a LangGraph sort of approach. Yeah.
Very cool. Chris,
Plus,
thoughts?
then you don't even need to manage anything. You just use words.
Yeah,
although
using
words is hard for some people.
yeah. Using words is dope. I mean, so our workshops primarily use LangGraph, but we do have the kind of from scratch implementation. So in our recent workshops, we start with building like a really basic from scratch agent, and then we move on to doing the same kind of thing, plus and LangGraph. At the end of the day, all of these tools are tools, and the patterns behind the tools are much more important. So along the same lines of what Matt's saying, but perhaps a little bit more on the framework side of things is like all the frameworks do the same thing, right? Like they do it. That's not literally true, of course, but they do very similar functions. They help you do the same kinds of things using whatever your favorite APIs are, right? So like Pydantic API, it's so close, right? A lot of people are already familiar with that. And so the idea is that we have this underlying set of patterns we care about, like tool calling, like, the agentic loop, like a workflow, right? And all of these tools help you implement that. You certainly don't need it. You can certainly start from, or even finish with, just describing that to GPT-5. I do find that starting with something like LangGraph for people who are coming in without the wisdom can help keep you on rails enough that like locks you into the mindset. And then I think people will then find themselves progressing outside of it as they get more creative. But there can be useful training wheels for those getting started in the frameworks.
Another reason to use that is actually because oftentimes I find people know how to use GPT-5 Pro or whatever to code something up. Then they say, how do I actually host this? That is the biggest reason something like Lovable is growing so quickly, for example. So in those cases, if you're somebody who, doesn't know how to put some code into a box and put it out to the world, that's another reason to use something like LangGraph, just as an example.
Yeah, I think to your point earlier when you were saying, really the challenge is the ambiguity and people not describing things well. I remember having this conversation with Zhao, the founder of Crew AI, and having a really good conversation with him. And he was like, a lot of engineers who are really good at code and building out their apps there aren't great at being able to express and describe how to get the agent that they want. And for them, especially if they're non-native English speaking as well,
that's fair.
They have a massive library of they can scan through and go, I want the outcome of X. And you can pull from this library out there. And what I found is a lot of people learn from those libraries, much like you were talking about starting with Bubble. And then eventually you're like, I don't need this platform anymore, right? Like, how do I mature for my needs in the application? So I just love that there's so many options for people to be able to get to the end result. Because, right, back in the day, and I'm probably the old fart on the call, but if you're coming out of the 80s and 90s, it was an if this, then that world where you were living in a very linear processing structure for your software. And it was very hard to come at things sideways. And the way that prompting and everything has worked currently, there are always so many different directions you could take into the end result, which is why I think we're still seeing so much novelty and innovation.
Yeah.
And one thing I want to make sure that we mention, because I think you hit on a super good point here, Mark, which is that like the LangX ecosystem is huge and well integrated, and it integrates with everything from evals to X to Y, right? The Llama Index, Crew, all of these different frameworks. I mean, they offer really pre-built integrations with a lot of tools that does reduce kind of your need to produce elements that you may not have any understanding of, and may wind up in some gotchas if you do go just totally self-made. That I think is like really important for knowing it's going to be running in production, knowing it won't go down. And this is before you've had the experience of seeing these systems work in production to have learned kind of some gotchas. So they serve their purpose, absolutely. And I think starting with whatever level of abstraction you're at when you get started, right? And then just you wind up over time, just like Matt described in his own journey, you just wind up sinking to the bottom eventually, right? Like you wind up getting to that final layer of abstraction, which is 0 layers of abstraction.
0 layers of abstraction. Well, I know we're coming up on time. I want to ask one more because I think it's a good question, and then I also want to give Matt the chance to actually maybe flash up on screen his open source projects for other people if they want to see his Git, anything like that. I think we love sharing resources and tools with the community. We want you guys, stargazing and forking these projects. We want you joining us as well. But while he's bringing that up, this other question was, how do you check for the ambiguity in domain-specific data sets, especially when we are training for tool calling? So, Chris, while Matt's bringing that up, what are your thoughts?
Yeah, I mean, ambiguity is not that difficult to check for at the end of the day, right? Because what we want to see is we want to know that when query A comes in, it calls tool B like every time, right? Or that set of query A calls tool A every time. And so essentially what you do is you just think about your application, what tool should be called in what situation. And then you can use something like synthetic data generation to build out an actual test set for this, to bake it into an evaluation. But in reality, like, every query to look at it, like as the developer, which tools should be called when. And I think leveraging your own expertise or having people on your team lend their expertise, SMEs, really, we know what the application should do at every step, right? Because what we're trying to do is build something that emulates our knowledge to do it, for us. And so I think it seems more daunting than it really is. And building those tests is just about doing the hard, laborious work of creating some tests, test scenarios, and creating some prompts that what the outcome should be. And you're able to test that. And you can use LLMs to help augment that, to maybe find some gray areas, right, between these use cases. But at the end of the day, we all know where we would start on any given problem if we have a set of 5 tools. And if we look at a prompt and we don't know where to start, then there is ambiguity, and we need to resolve that.
All right, I see people calling out for the share the Git. So I'm gonna put Matt's thing on stage, Ethan. All right, Matt, why don't you give us a quick tour here of what you're offering, folks?
Yeah, so I just pulled up a few, and there are others of my recent GitHub repos that you can kind of check out. This is the one we actually showed today. So this one's called GPT Pro Mode. It's a collection of Pro modes for a bunch of different models. We have GPT-5, which obviously now there is a GPT-5 API as of yesterday, which is fantastic. So that one we can nix, but the rest is pretty cool. There's Nemotron, there's other OpenAI models. You can throw Claude models in there, pretty much anything. So you can check this out, and there's Colab notebooks.
Appreciate you including us in there.
Of course. Second one I actually put out like an hour ago, or a couple hours ago, called Sora Extend. This one's really cool. So you probably saw Sora from OpenAI come out yesterday. The problem with it is it only allows you to generate 12-second videos, which is quite limiting. This uses a new technique with prompting that I developed that sort of blends videos together with prompts to allow you to go beyond 12 seconds. You could, in theory, have multi-hour or multi-day videos generated by Sora. That might be a little expensive, so I recommend making sure you're checking out the cost first.
Be careful.
But I put this out just a couple hours ago. You can see more information on it on my Twitter at Matt Shumer _ if you want to follow me. This is another one that I've done that was incredibly popular. I mentioned it before. It automatically does prompt engineering for you. It works on classification prompts. It works on generation prompts. It can even instruct prompts to base model prompts, although that's not as necessary anymore. Even, if you just want to learn from this, there's a lot of really interesting prompting work that I did in this. It's a couple years old, but the ideas here kind of underpin a lot of what's going on today. This is a more recent one, a little bit more technical, but I did this in partnership with OpenPipe, which actually just got acquired by CoreWeave. it essentially uses the reinforcement learning framework, but it builds an AI system on top of it to automatically train a model with RL. You describe the model you want. For example, I want a model that's really good at generating Python functions for X, Y, and Z. And it literally takes that from there, generates training data, generates scenarios, generates verifiers and rules, and it uses reinforcement learning to actually adjust the model's weights with reinforcement learning to get really, really good at that task. It's super cool. Also, a lot of stuff to learn from here. This is a bit more of an advanced example, but just this is some of the stuff I do. You can follow me, as I said, on Twitter at Matt Shumer right here. Yeah.
That's excellent. I see some people asking if you could copy and paste those into the chat, some of those URLs.
I can. Let me join the chat.
And then just to close us out today, there was one question that came in before the stream. Someone asked, how does NVIDIA use AI internally? Does every employee have a, account with a ChatGPT, Claude, Gemini, etc.? I think the short answer to that is, Chris, yes.
Yeah.
Yes. We have all of them. All of the above. Many people use them. It is integrated into our everyday tooling, and we walk the walk that we talk. Every leader here wants the staff to be adopting AI tools, experiencing the AI tools, and I think most importantly, we want to be able to relate to the customers of our customers. What is the experience like for them when they're using these applications every day, and how are they advancing? It's the same reason why we're developing models and why we're allowing everyone to have access to the data transparently. We're not competing with anybody on this. We're contributing. And that's why we make that data available. Like we said earlier, one of our customers, ServiceNow, even beating us in benchmarks by using that data to retrain their own model. We just want to see everybody advance this space in the AI ecosystem. So yeah, we all live it. We all love it. We all use it. And I don't think that's stopping anytime soon.
All AI all the time. You've got to use it if you work at a company making it, right? You must know what it's like to prompt a model in order to build a model that's fun to prompt. You've got to know how inference works in order to build a model that does well at inference, right? I'm going to tie us back one more time to what Brian said, which is like, this is really a way to make sure that everything, the whole stack from top to bottom, from code to hardware, is working well for AI. You have to use it. And we are privileged enough to be able to use it a ton here, and it helps everybody. And it's just, it is, I think it's a tool you just got to get used to using in 2025.
Yeah. I'm going to ask
real quick. I'm not able to put for some reason, I'm not able to put the links in the chat. I don't know if Mark or Chris, you guys have the ability to do that. Also, I see Technium in the chat. If anybody's a bit more technical, you should follow him as well. He's more on the training side with Noose. Really, really helpful content. Definitely give him a look as well.
Sounds like Matt's going to help curate some new guests for future streams. I think we found our guest pimp.
I'll try my best.
There you go. Well, if you want to be able to do more, learn more, play with the models yourself, Ethan, as always, on point, has up on screen. You can check some of these models out that we were discussing today at build.nvidia.com. Model cards, all your information there, as Chris mentioned. And then, of course, we have, if you ever want to email us, like it's 2002, you can always show the other slide here, Ethan, that has our community email address. community@nvidia.com. You can connect with us there, send questions. And if you're building something rad, we want to see it, right? We want to see what you guys are making. We want to hear about it. Maybe we invite you on as a guest to actually show your demo. And with that, I'll say a very special thank you to Matt again for joining us. I always appreciate you, sir. Appreciate your tweets, appreciate your innovation and your transparency with the community. So thanks for joining us.
Thanks for having me.
All right. And with that, Chris, I hope I get to see you again while you're visiting Austin, Texas with me down here. We had some barbecue last night. I think we got to go do some breakfast tacos before you leave, and keep cooking in that kitchen. And we will see everybody next week, next Tuesday, same time, same bat channel for the next Nemotron Labs stream. Thanks, guys. Have a great rest of your day.
Peace.
Bye.